Hello you 10s and welcome back to mathematics. In this video I'm actually going to be adding on an extra bit onto our topic of trigonometry. We're going to be talking about today about a thing called bearings and talking about how they are used to tell us about what they are used for and how they tell us direction. So in today's lesson that's what we're going to be focusing on. So, learning intention success criteria are up there if you want to have a look at that. Let's just quickly talk about what bearings are. Now, definition. A bearing is a method of writing angles used for giving directions between objects. So here, this is one of these applications of this whole topic of trigonometry that we've done. Bearings is a way that we can tell the direction between different points. Let's say, this is used for navigation for pilots, hiking, warfare, and etc. So this is actually used in a whole bunch of different real-life examples. So for example, on the left, we have a pilot's aerial map. So this is an aerial map telling pilots where they can fly back in the days when we used to be able to fly out of this country. It tells us tells a pilot what their direction is. And so if we want to be able to tell a pilot, okay, I'm going in this direction, how do we do that? And that's where bearings comes in. Another application of this is when we are hiking, for example, or if you go hiking, you might want to be able to tell someone, okay, I want to go in this direction and I'm going for this long and this far. And this is where bearings are used. Bearings are used to describe the location and direction that someone is going in. So that's what we're going to be looking at in today's lesson, bearings. Now, with bearings, there's a few things we need to know. So notation for bearings. Bearings have three things that I've noted here. Bearings, firstly, start at north. So here, if you have a look, bearings start at north, 0 degrees. So if you have a look at my diagram over here, we've got like a compass with the four directions: north, south, east, and west. And if you have a look at the top here, north is 0 degrees. So all my bearings, we're going to start at north. That is 0 degrees. And the second thing that we're going to notice is that it goes clockwise. When we're measuring the angles for bearings, we are going in a clockwise direction. We're going in a clockwise direction. And the final thing is that bearings are written with 3 digits. So for example, I've got 3 examples here and I'm actually going to write them all in bearings. So here, if you have a look at the red line, we've got this little angle over here and it says it's 8 degrees. So if I was starting, so here, when we're talking about bearings, let's say this is a point O. Someone is going from point O and they want to go in this direction like a northeasterly direction. And we want to figure out what this bearing is. The way we would write this first one is, well, it's 8 degrees and we're starting from 0 at the top north. And so here, this is going to be 8 degrees, which is fine. So that is going north, starting from north and going in the clockwise direction. However, because we need to also write this as a 3-digit number, the way that we would write this direction is 008 degrees. We need 3 digits. Notice here, I've got 3 digits. And so if I want to write this particular direction in bearings, I would write that as 008 degrees. Okay, let's have a look at the other one, the next one. The next one is this 10-degree angle between east and south. So this is in the southeasterly direction, the green line. Now, firstly, notice here, this 10 degrees, it doesn't start at north. This 10 degrees started from this east direction. And so if I want to actually figure out what this bearing is, what I need to do is I need to actually figure out what the whole angle is, starting from north all the way down here. And the way that we can do this is going, okay, hang on. This angle to get from north to east, this angle over here, is just 90 degrees. So east is 90 degrees. And what we're going to also notice is that all my other directions, so east is 90 degrees, south is 180 degrees, and west is 270 degrees. So they're all 90 degrees apart from each other. So if this is 90 degrees, and then I've got another 10 degrees there, this point over here, this direction has a bearing of 100 degrees from north. Because when we add together that 90 and that 10 degrees, we're going to get 100 degrees. So this point over here has a bearing of 100 degrees. Now, I've got one final example here, and I realize I put this in the wrong spot. Now here, let's imagine this is, I'm going to do this direction, 60 degrees. Now, let's just remind ourselves. So bearings start from 0, north. North is where bearings start, and they go clockwise. Now, if you have a look at this angle over here, this angle over here is not in that clockwise direction. It's actually 60 degrees anti-clockwise. It's 60 degrees anti-clockwise. And so if I want to figure out what this angle is, there's actually a few ways you could do it. You could actually figure out what this whole angle is, starting from 0 all the way around. So if I draw this, and this is going to get a little bit messy, all the way around to here, to get to that point there. So we need to do 270 plus a particular angle. Or we can go, okay, actually, one full rotation. Now, if you remember from angles when we looked at it earlier in this year, angles, when we go one full revolution around like that, that's 360 degrees. And so if I go 60 degrees in the opposite direction, I'm actually going back 60 degrees. So here, this direction, this point over here, that's a bearing of 300 degrees. Okay. So that was just a very quick kind of like overview of what the bearings notation. So 3 things about bearings. Bearings start from north at 0 degrees. They go clockwise, and they are always written with 3 digits. And so what we're actually going to do is we're going to solve a few problems involving bearings. The first thing we're going to do is actually writing, identifying bearings from different points. The other thing to be very careful of, and I actually should have said this before that point, is be careful of where the bearing is being taken from. And in this first example, we're going to have a look at what that actually means. So, identifying bearings. In example 1, what we're going to do is we're going to write down the bearings of, firstly, A from O and O from A for the following diagram. So you have a look, we have these 2 points. We have O, the origin, and we have A, this point over here. And what we want to do is figure out what direction is it from O to A, and what direction is it from A to O. Now, this notation, if you want to write a bearing A from O, this bit at the end, from O, just tells you that O is the starting point that you're looking at. And we're trying to find the direction of A from O. So what I want to do is I want to figure out what this bearing over here is. What this bearing over here is. Now, if you remember from that example, when we went through that notation, firstly, we start from north. North is 0 degrees. And we go clockwise. So here we're going in this clockwise direction. In the diagram, they tell me that this angle over here is 38 degrees. Now that 38 degrees is actually starting from the east. And so what I need to do is, this bearing isn't just 38 degrees. I need to actually add on this extra angle over here, this section over here between north and east. Now if you remember from my diagram up here, between my north, east, south, and west, there's 90 degrees between them. So between north and east, it's 90 degrees. Between east and south, there's 90 degrees. Between south and west, there's another 90 degrees. And between west and north, there's another 90 degrees. So what this tells me is that this angle over here is actually a right angle, and that's 90 degrees. And so if I want to find that whole bearing, what I need to do is I need to go 90 plus 38 degrees, which will give me 128 degrees. And so therefore, my bearing of A from O, is equal to 128 degrees. So that's this first part here. If I want to write the bearing of a bearing from a certain point, I just want to figure out how many degrees is it from that north. So starting from the top, from north and going clockwise. But that's for part 1. Now part 2, I want to find the bearing of A from O. Now notice here, this is just the opposite thing. Opposite. Notice here, compared to the first question, what we've done is we've just swapped A and O. O from A is actually asking us to take the bearing if, instead of O being our starting point, A is our starting point. And so let me actually redraw this diagram, but have A in the middle. So if A is in the middle, we've got east, west, north, and south. What we want to do is actually figure out this angle over here. So here we want to actually figure out what the bearing is of O from in this direction. Now the thing that we know is that there is the bearing from O to A. There's that bearing, and if I draw up my thing, there's at 38 degrees over here. Now, if you remember from our angle relationships that we looked at earlier this year, this actually forms a set of alternate angles on parallel lines. This is a Z angle. So what this tells me is that this angle over here is 38 degrees. And so if I want to find the bearing of O from A, what I need to do is I need to go, okay, that's 38 degrees there, but I need to also add on this whole angle over here from north all the way to west. And that's actually 270 degrees because west is at 270 degrees of a bearing. And so here, for this second one, for part 2, I'm going to go 270 plus 38 degrees, which will give you 308 degrees. And so here, for this particular example, therefore, the bearing of O from A is equal to 308 degrees. So for this one, we actually need to draw a separate diagram to actually visualize where that bearing was. Okay, so that's how we can write bearings of different points from each other. The other thing that we want to be able to do is actually figure out lengths and from a bearing. So from a question. And so what happens is often when you give someone's direction, you're actually also going to give a length. I'm going to a length that they travel that particular direction of that bearing. So for example, you might be traveling at a bearing of 25 degrees, 0 to 5 degrees, and you've traveled that bearing for 8 kilometers. What you want to do is often want to figure out how far west, how far north, how far east you are of a particular location. And that's what we're going to be looking at in this next example. So we're going to be solving problems involving bearings. So here there's actually 2 points. First point, if not provided, draw a diagram. So if the question doesn't give you a diagram, what I recommend is to draw a diagram based on your question. And then the second part is most often you're going to need to use trigonometry to either find a missing side or missing angle. So using the skills that we've looked at in this topic of right-angled triangles so far, you're going to need to actually apply some of those skills. So let's have a go at this question. A walker leaves the camp C and walks at a bearing of 250 degrees for 8 kilometers. How far west, x kilometers, is the walker? Show all this information on a right-angled triangle, then solve for x. Okay, so for this question, what we want to do is we want to draw a diagram first so we can actually visualize what's happening in this question. Let's have a look at the question and we'll see what information is important. First, let's read through. A walker leaves camp C. So here, we're saying that our starting point is C. So at the middle of my diagram, I'm going to have C for my camp. Okay, so what might be helpful is to draw my compass. So I've got north, east, south, and west. So I know that I'm starting at C. The camp is over here. I'm just going to draw a little camp. We've got campsite at C, and we're walking from there. Okay, let's have a look at the next part. They then walk on a bearing of 250 degrees. Now, bearing of 250 degrees. What we want to do is figure out where's 250 degrees. Now, 250 degrees. What we need to do, if it's a bearing of 250 degrees, we start from north at 0, and we just go 250 degrees clockwise. So here, 250 degrees, I would go clockwise. Let me do it bigger. I'll hit east, and that would be 90 degrees, and I keep going. I hit south, that's 180 degrees. That's still not 250. And then, if I got another 70 degrees here, that's my bearing of 250 degrees. So that's 250 degrees. Now, if you're not sure which particular quadrant, or like whether or not you're in northwest, northeast, southwest, just think of those numbers. So we've got 0, 90, 180, and 270. 250 is past 180 degrees, but not quite at 270. And so here, what this tells me is that 250 degrees is over in this southwest direction. And in particular, notice 250 is just, so if I do 270 minus 250, that's 20 degrees, and that tells me that there's actually 20 degrees over here. Okay, and that's actually going to be helpful for me as well in the following part. They go in this direction for 8 kilometers. So what I'm going to also label on in my diagram is that this length over here from my point where the walker has left. So let me put W for the walker. This length is 8 kilometers. So this length from here to here is 8 kilometers. How far? So let's have a look at the rest of the question. So here we've actually just drawn on the diagram all these pieces of information. Let's have a look at the question. How far west of the camp is the walker? So what we want to do is we don't want to find how far away from the camp he is. We want to find out how far west he is. So we actually want to find out this length over here from the camp all the way to however far west he is. We want to find this length over here. Now, if you have a look at this diagram, if I just join these points up, we actually can form a right-angled triangle. So if you have a look, I'm just going to take this point here. I'm going to draw this right-angled triangle. It would look something like this. I've got this length here of x on the top part. So we want to find this length x. We know that from the walker over here to camp back in the center, that is 8 kilometers. So I know that this length over here is 8. And the other thing that we found earlier was the angle in here is actually 20 degrees. And so here, I've actually gotten, from my diagram, I've created this right-angled triangle. And with our right-angled triangle, we can actually use trigonometry to help solve for this. So we've drawn this as a right-angled triangle, and all we need to do is just solve for x. What we did with our right-angled triangle was firstly, we want to label our 3 sides. So I have this angle 20 degrees here. That's the angle I'm going to be using. And I've got my opposite side over here, O. I've got my adjacent side, A, over here. And I've got my hypotenuse, 8. And so here, notice I've got my 2 sides, A and H, I have got values for. So A and H, that's actually cos. And so I'm going to write my trig equation. Cos 20 degrees is going to equal to adjacent over hypotenuse, if you remember. So cos is equal to A over H. And so here, this is going to be x over 8, because that's my adjacent side is A, x, and my hypotenuse is 8. And so here, this is the trig equation that I'm going to have. Now, x is at the top, so my numerator. So what I need to do if I'm going to solve for this is, therefore, x is going to be equal to 8 times cos 20 degrees. And so if I want to find the length, how far west the walker is, all I need to do is just put this in the calculator. 8 times cos 20 degrees. And so that's going to give me 7.51 or 7.52 kilometers. So that's how we can actually use our bearings to help solve for missing value, figure out lengths. So here what we had to do was we had to firstly draw a diagram to represent my scenario. So here I used my bearings to actually identify that that 250 degree bearing is in the southwest kind of area. And then from there we can label on our 8 kilometers on our diagram, and also figure out that there's a 20 degree angle here. Then once we've drawn all of that, we can actually figure out a right angled triangle based on that diagram. So here I drew out my right angled triangle, and then using trig, I can use that to help me solve for my missing side there. So that's it for today's lesson. If you have any questions, feel free to email me or send me a message via Google Classroom. I'm more than happy to try and answer your questions there. But until next time, Year 12s, Year 10s, I'll see you in the next video or next term. Bye.